Okay, Cretans, we are still busy with the series number of questions in preparation for Money's paper. I'm having this a nice question there, which is counting 18 marks. This question is counting 18 marks. Okay. It reads as follows. Strontium is the best known for the brilliant reds it produces from its salt in fireworks and also flowers. So now the strontium is an element on a periodic table in period 5, group 2. So now you can see that it produces the nice color there. This actually the color for this one must be red. The color it must be red. So a dope red color. Then the 4 isotopes of this element, these 4 isotopes, and the mass number 84, 86, 87, 88. Then now this is a relative abundance percentage. Then we define the following term, the isotope. Okay, can you just go through to this question by yourself? Then we can look at the stem at the top. I don't have any information, but the information is from at the below of those color of strontium. Then now this is the information that you can copy. Then you can pause this video and try to answer for yourself. So okay, now let's look at the answers. You pause, then you do it for yourself, then thereafter you mark your work. Okay, let's look at the answers. The 4.1, you define the term isotope. We know the isotope, it must be what? An atom of the same element with the same number of protons but different number of neutrons. Or you can say same elements with the same number of same atomic number but different mass number. So this is an isotope. We can have an isotope magnesium 12, 24, magnesium 12, then 23. Same the number of what? Number of protons, but different number of neutrons. Okay, so that's the meaning of an isotope. Write down the symbol of strontium. The symbol, it must be SR, because we're going to get it. You look at period 5, group 2. This is important. Period, we move horizontal. We talk about periods, but now vertical, we talk about the groups. So now you go to group period 5, group 2, then you're going to get that element there, which is SR. So it must be an answer for 4.2. So how many valence electrons does this strontium have? For the valence electrons, how many valence electron? Okay, let's look at this answer. Must have 2 valence of electrons. 2 valence of electrons. So then 4.4, you compare this one. We need to be careful with this one. Compare the atomic radius of strontium and also the magnesium. So go to exam guideline and check atomic radius. So according to this 4.4, now atomic radius decreases across the period and increases down the group. So now the atomic radius decreases across the period. Across the period, it decreases atomic radius and increases down the group. So strontium atomic radius is bigger than that of magnesium. So strontium atomic radius is bigger than that of magnesium. So 4.4, be careful with that question there. Okay. Then calculate relative atomic mass of strontium. So you calculate relative atomic mass, you add, remember, so we have at the top there, I'm having 84, 86, 84, it goes hand in hand with what? 0.56. Then we add 86, goes hand in hand with this one. 87 goes hand in hand with 7%. 88 with that one. That is why if you see in our answers there, so now the percentage must be out of 100 is divided by 100. 84 multiplied by 0.86, so it's 84 multiplied by 0.56 plus 86 multiplied by 9.86 plus 88 multiplied by 7 plus where's the other one? 1 2 3 4 5, 1 2 3 4. So then we have 1 2 3 4 divided by 100, so we get most probably is going to be 87.71, which is equivalent to 88. So I'm sure you still remember how to calculate this. You still remember how to calculate this. Okay, this is counting 3 marks. Then now nitrogen is a nutrient that is the most essential for plant growth. Nitrogen, the fractional distillation of liquid air. This is how we extract nitrogen from air to produce the fertilizer. So calculate the percentage of nitrogen in this fertilizer. So firstly, we're going to calculate what? We're going to calculate the total. I'm having 149. So the total relative mass for the whole compound is 100 and the whole part is 139. So you multiply by 100. But specific, we are specific, we want to calculate percentage for what? For nitrogen. So nitrogen, how many nitrogen do I have there? So I'm having 3 nitrogens. So how many nitrogens? This number outside the bracket, this is for hydrogen, this is for also nitrogen. So this is how nitrogen, it must be 14. So let's look at the nitrogen mass is 14, but how many nitrogens do I have in ammonium sulfate? I'm having 3 there. So you multiply by 100 the percentage. So that just to multiply by this 100, you're going to get the mark for that. And also 149, you get the mark for that. 3 into 14, so the percentage for nitrogen is 28.19%. So actually the fertilizers in grade 12, so we used to calculate the percentage of each. Okay, then now 4.7, now this is interesting part. The manufacturing process of fertilizer used a compound containing this. So you need to calculate the empirical formula here. So we know it will be the number of moles mass over the molar mass for this compound, 82 divided by 14. This is for nitrogen. So then for hydrogen, the mass is 1. So you're going to get this. Then you divide by simplest whole numbers. Remember the empirical formula, the simplest number. So the ratio is 1:3 there. So now nitrogen 1, hydrogen is 3. So that is ammonia, not ammonium, because ammonium is NH4 plus. So we don't want this one. And even here, the ratio can tell N, this is 1:3. So this is 2 H there. So meaning 1 nitrogen, how many hydrogens is 3? Not ammonium, like indicated in our memo there. Okay, that was a nice question. All right.